Hello everyone, welcome to this new FAULHABER webinar. Just a few words about FAULHABER before starting. FAULHABER was founded in 1947. The headquarters is in Germany, in Schönau, 20 kilometers south of Stuttgart. And now the management is at the third generation with 14 locations worldwide, development, production, and sales offices. And with a distributor network, we can reach all the world. As a provider of a drive system solution, we can produce and distribute motors in several technology: DC, brushless, stepper, linear motors with encoders, with gearheads, lead screw, ball screw, and the drive electronics to get all the material that you need for your application in one source. As you can see, 30% of the business is made by standard solution, what you can choose in our website, off-the-shelf components. 40% is a modified solution, whether you need special shaft, special mechanical interface, connectors, or sensors, and so on. And 30% is complete customized solution tailored around your application. Just a few words about myself. Welcome to this webinar. My name is Mario Zecchin, and I work in the FAULHABER group since 2007, first as a product manager for motion control. Now I'm taking care about trainings, webinar, e-learning system for our sales force inside the digital sales system. So what we want to show you today is a new compact, flexible, and universal motion controller. Giorgio will take care about the possible question coming during this webinar. And for the most complicated question, we will answer separately later after this webinar. What we want to show you today, so it's the new MC3602, 3606B motion controller. We will explain everything later. What is the main features, what is the main controllable motor technology that we can control with this kind of motion controller. We will talk about motherboard integration design, because you see this is a connector, is a plug-in connector, so we will give you most of the important information how to integrate this motion controller inside your electronic system. Then we will see how easy it is to configure this motion controller with the help of Motion Manager, the version 7, commissioning and drive system, how to make the first steps with this drive, and some application example of use of this motion controller in several topologies. So we have two new kids on the block in the motion control world. You can see we have the MC3602. This is a smaller one with one connector where you can have every I/O and every motor connection, and 3606, this larger one with a separate connector for the motor phase, because we need higher current to operate the larger motors. The letter B means board-to-board connection, so this kind of connector here that you can use it for plug-in and play in your application. Then we have the P, means pin connector. There's another type of connector that we are using, or the S is with the standard connector. A standard connector means that you have a standard way to connect a motor, encoder, and I/O. So to have an idea about the characteristics, the rated current at the 36 volt, 3602 means 36 volt of maximum supply voltage, 2 ampere of maximum continuous current. The peak current is possible for a short time and is typically 3 times the continuous current. So with the MC3602, we have 2 ampere of continuous current and 6 ampere of peak current at maximum 36 volt. The MC3606 on the right side, we have 6 ampere of continuous current with a peak current of 3 times higher. What is the type of motors that we can control with this kind of motion controller? We can control every FAULHABER motor technology. We can control DC motor. We can control brushless DC motor with hold or with encoder. We can control linear motors. We can control stepper motors. And you can also see the type of sensor that we can use. For example, digital analog sensor for the brushless and for the linear motors. Incremental encoder, 2 or 3 channel differential also. So with a line driver to get a longer cable without much disturbance on the encoder signals. And then we have also the absolute encoder, the single turn absolute encoder and the multi-turn absolute encoder with the corresponding normal standard interface. We have 3 digital input, 2 digital output, and 2 analog input that can be also used in application to detect digital values. We have a status LED and additional digital output for the diagnostics to check the working mode of the controller. And we have a communication bus USB, RS-232 CANopen, and EtherCAT additional. But we will explain later this, as in the next slide. We have 3 different field bus for different communication performance. RS-232 typically is for 100 millisecond command cycle, so you can send one command after the other with a 100 millisecond cycle. It's a very typical use for point-to-point connection and small network. CANopen is much more reliable and faster. It's around 10 times faster than RS-232. You can go down to 5 millisecond command cycles, but if you need higher performance in terms of communication, then EtherCAT is the ideal, down to 500 microsecond command cycle with very complex applications. In this controller, we use field-oriented control. This allows us to have the best motor control. High efficiency, we can reach a very accurate dynamic response to the load variation, and we are able to make a fine motion control. This makes ideal this kind of controller for robotics, industrial automation, medical application, and other applications where you need high performance and a large type of motor to be controlled. And depending on the type of sensor connected to the motor, we have a broad range of controllable speed and a stable acceleration and deceleration phase. As a standard, we have a speed and position mode where the acceleration and the deceleration are calculated inside the motion controller, while we have another type of control is a cyclic synchronous position, cyclic synchronous velocity, or cyclic synchronous torque control. And in this case, the acceleration and the deceleration are calculated inside the master. So which kind of motor can be controlled with this motion controller? The small motor are best controlled with the MC3602. This is because the calibration current is ideal for controlling small motor with a small nominal current. If you need larger motor, so the MC3606 is the ideal solution for controlling this kind of motor because the calibration current has been tailored for the larger motor. You can see here we added the stepper motor family to the controllable motor technologies with our motion controller. So the larger stepper motor are controlled in the ideal way from the MC3606, and the small stepper motor are best controlled with the small 3602. If you need fast prototyping, then it's necessary to use an evaluation board. This is the easiest way, otherwise you have to design your own board. It takes a lot of time. At the beginning of the project, probably you need just to see if the motor can be good control in the application. So at the beginning we suggest to use fast prototyping. This evaluation board, this is one of them. And you can have all the connector for motion, for the motor phase, for the sensor, for the encoder, for the I/O, for the communication bus, onboard USB connection. You find it here directly in the motion controller to get easy configuration with motion manager software. and every evaluation board is delivered with a connector set. Which kind of evaluation board to choose? We have this one. You can, what we will use later for our demo is for RS232 and for CANopen, and this is ideal for the MC3602. And the larger one is ideal for MC3606 because you see we have the two matching connector, and we also have the possibility to have the EtherCAT connection. We need another small adapter with the ASIC for the EtherCAT operations plugged here, and then you see we have the two RJ45 connector for EtherCAT. In this case, so with a simple CANopen and the RS232 configuration, you just use this simple adapter board, evaluation board, and for the other larger evaluation board is for the larger motion controller. But if you want to integrate in your control board the motion controller, then we have designed a dedicated application notes. Where you can find it, just go to FAULHABER.com website. Like in this case, you go to the know-how section, you see the application notes, and then you can search for the application note related to the motion controller. Just scroll down to the latest one, and you will find application notes 198, and this is the application notes for the how to design the right board for your application using the MC3602. And you can see that we have a lot of information related to this motion controller. You can click on the drive function manual, opening also the manual. You have information about the dimension, the type of the connector used, and the pin enumeration. For the details, refer to the user manual. And also for the MC3606B, you have the two connector description with the part name in case you need to use it in your control board. But if you need to integrate these motion controllers in your control board, then we have an application notes. This is the application notes that you can download, where you can find it in the FAULHABER.com website. Inside the know-how section, you see the application notes section. So open it and scroll down until you find out your application notes. In this case is the application notes number 198. Designing a motherboard for MC3602. You can download in English. Once this is downloaded, you can open it. With the Adobe Acrobat, you can have a lot of information related how to integrate, how to design the motherboard for this kind of motion controller. You can also open the drive function. You can see other application notes for shielding and to minimize the AMC noise. This is the dimension of the 3602 with the type of connector used. And in this page, you see the 3606 with the dimension and with the type of connector used in order to integrate this for in your control electronic. Then other information related to how we recommend to design the PCB, how to make the shielding, how to make the correct let's say filtering. This is the evaluation board that you have seen before, and also information about how to make shielding of the cable for the motor phase. Even the EMC filter design for the supply input. Then let's have a look at the configuration with the Motion Manager software. This is the motherboard. You can see that you have the USB connector to be connected directly to the PC. This is the connector for the motor phases. This is the connector for the sensor, the whole sensor, digital or analog one. The encoder with differential input available. The power supply and the digital I/O and the analog I/O available in this board. And the communication bus, CANopen or RS-232. You can select here with a dip switch whether you need to use the RS-232 or the CANopen. When you open the Motion Manager 7, you have a picture like this. So you have to add the new drive, select the USB serial device, like in this case, in interface COM or USB, and then you can click on the apply, and then you will see the drive here. But I don't want to show you like that. We go live on the evaluation board and on a small demo that we built. So I need just 1 second to switch the camera and to see to connect the other camera in order to show you the demo. Okay, so we are connected with the webcam. You can see it on the right side, the small demo with a disk with a stepper motor installed, and the Motion Manager is a default when you first of all you connect the board. Just have a look at the board. This is the controller, this is the USB connector, and this one is the power supply connector, the encoder connection, and the motor phase connection. First of all, I want to show you, if you don't know which kind of motor to be connected, then you can choose the type of motor immediately after the first connection. So first of all, we have to add the new drive. You see the interface USB connected to the Motion Manager. Then select the node 1 is MC3602B. So apply, and then you will see the motor selection is the first step to do. So let's click on the motor selector, and we have a stepper motor. But if you don't know the type of stepper motor that you have, you set the motor manually. Then you take a name, for example, stepper 01. Select the stepper motor, and then we click on identify motor parameters. In this case, we need to select the step angle. This in our case is 15 degrees, but if you have an NEMA motor with a 180 stepper revolution, you have to change to 2 degrees, for example. And the nominal current in this case is 1 ampere. So we can start the identification, and the Motion Manager send signal to move, to shake the motor, to make a speed test in order to identify the torque constant and to identify the motor resistance. At the end of the process, you have an estimation of the value of phase resistance and the phase inductance with the measured torque constant. Once we have this, we can close, and we can for example here select also the method if you want a full step or micro step. So just click on the apply, and we have done with the selection of any type of stepper motor that we have connected. We have to know what is the step angle and what is the nominal current of the motor phase. After that, we have to see the load transmission part. We have the units. We can select 0.1 degree of unit or number of increments, for example. Then the part of the system is a direct drive, so directly on the motor output. This part is for the thermal protection. We recommend to keep it active, this part, otherwise we may damage the coil. So once we have done this, we apply, and we have done also this part. The next one is relatively to the reference and to the limit of the systems. We can limit the speed. 32,000 RPM is difficult reached by stepper motor. We can put 5,000 RPM, for example, as a maximum speed. The current limitation is 100%, but we can also change this, for example, 80% of the rated motor current. If we have a switch in the application, for example, using a lead screw or a ball screw where you have the limit switches in the application, or if you have a rotary disk with a two limit switch, we can select the type of switch, for example, here, which digital input is related to and the polarity of this. In our case, we don't have any switch, so we keep it simple. After that, we apply on this. We have done what is missing now. We have to optimize the drive performance. In this case, we can click here and we can optimize the parameter for the positioning task. In this case, we have a set point of 1000 increment, but we can make a lower, let's say 100 increment. This is the steps. And we have to turn on the driver, switch on the output stage. Let's click on the one step response and see what happens in the driver. The motor is moving and you can see in 100 step, this is the step response. You can change the velocity, you can change, for example, the acceleration and the deceleration. With the advanced setting, you also can set the window in increments for the overshoot, for example, and how much time the overshoot can occur. In this case, we don't see any overshoot, so I guess we can keep it like this. If you want more option, then you have the possibility to see the velocity actual value, the torque actual value. So during the operation, you can change this and you can see the different graphs. In orange, you see the speed, and in blue, you see the level maximum current, maximum nominal current of the motor. So in this case, we have a good result. So we have done it with the default profile parameter. After that, we have the mode of operation is in position, and with the communication means that the position value is given with the USB or with the RS-232 or CANopen. Operating mode is profile position mode, and here we can go to select which digital input we are using. For example, for limit switch, the polarity, the switching threshold is 24 volt because we use a PLC together with 24 volt value. We can change this value, or we can also define which digital output can be used for a brake control in case of an electromagnetic brake connected to the motor. The section with the analog input is when we are using the analog input for position control or for speed control. We have two analog input. The meaning of this is explained in one webinar. We don't need to discuss about this part now. Good. After the configuration, the commissioning, we can go with the operation, and the output stage now is switched on, but we can switch it off and we can move to the one defined position, switch on again. We can change the position mode and put some, let's say 100 increment relative from this position, and minus 100 increment relative to the position. So when we can also turn on the graphic analysis for that, and start the movement. You can see here the movement of the red, the movement of the rotor. You can increase this to 1000 increments in clockwise and counterclockwise, so you have a wider movement. You can see around 90 degrees. And then you can analyze here, you can drag this value and to see the positioning value, and in green, the velocity actual value. So you can see that it's quite easy to operate with this. So once you see that everything is working, so you just click on the save button. The settings are being saved, not switch off the device. until this is saved. Okay, so we have configured all our driver match with the motor in open loop, and all the reference switch or the command source has been defined. What happens if we have a defined motor? For example, in this case, we have a FAULHABER stepper motor, and then we click here on the motor. We have a stepper motor, so we go up in the AM2224 motor. We have, you see the 1000 is the type of winding. So is connected to the motor M1. What does it mean is if you need to know what is the M1 connector, just click here and go to the motherboard information. You see that for stepper motor connection, the M1 connector is a connector like this. We have 4 pin, and 2 pin is for the motor phase A and the other 2 is for the motor phase B. If you have, for example, a brushless motor, we just need the 3 phase and we leave free the 4th connection. With DC motor, we just need 2 of them. We are working with stepper motor now. This is the motor. Set the motor manually. We have one encoder connected. Let's select also the encoder is a PE22120. Also in this case, if you click here, you see the pin assignment, and this is this connector here, where you can see the pin out and where the channel A and the channel B is connected, and with the characteristics. After that, we can see control in closed loop because we have chosen with the encoder. So we apply this. We have done. Once we have selected the motor and the encoder, it's necessary to make identification of the load. Here you see the load transmission in case of gears between the output shaft and the load. But in this case, we put the load to identify. So this means that with this option, the system is identified. You see that the motor is shaking and makes some rotation in order to identify the load. In this case, the load has been identified with the inertia of 7.6 grams per centimeter square. So apply this. We apply and it's done. After that, it's necessary to optimize the control parameters in order to have a good control. Let's have a look at what happens here with this default parameters. With the step response, we see how is the behavior. We have a slightly undershoot, so we can try to play with the parameters in order to see if we can improve the positioning. This is a little bit better. And after that, we can see. Once we are happy with this, we can apply the new data, and then it's done. At this point, we have done everything. So we can click on the operation and switch on the power stage and see from this position to make 1000 increment. Relative to this position, we can start the logger and the graphic analysis, and we can make 2 positioning tasks between 2 positions to see if everything is set up correctly. Then we can close like we have done before. We have to analyze the curve of position, speed, and the current, for example, here. We have one dedicated webinar for a motion manager characteristics, but this is what I wanted to show you. It's also possible to make a sequence program file. Here you have some code template on the right side. You can also open and define let's say demo program to upload in the controller, but it's not the scope of this presentation. We have one dedicated webinar for this. You have seen it before. So basically, this is what we wanted to show you related to the programming of the motion controller MC3602B. So let's go back to the presentation. Well, so coming back from the small demo, in many applications, there is no need to have a PLC or an external PC to communicate with a motion controller. In many simple applications, it's possible to use, for example, simple signal like a step and direction control to control stepper motor, for example, or to use an analog input to control the speed of a fan or the position control of a simple application. It's also possible to write a small program in order to react to some digital inputs and make some positioning or some other tasks of the motor. We use the FAULHABER basic language. It's very easy to use it. We have a dedicated webinar. Just want to show you where to find it. Let's go back to the FAULHABER website. From the home page, you go to the know-how section, and then you can see we have the webinar library where you can find all the past webinars that we did in the last years. And we have a dedicated webinar, this one, using controller basic for distributed local automation, where Dr. Andreas Wagner show you in a simple way how to write down the simple program for reacting to analog input or to digital input in one standalone application. Another nice source of information is the FAULHABER drive time in YouTube. We have some channels related to this, and getting started with drive electronics is a good starting point. You find a short video, 10 minutes, 5 to 10 minutes, where Andreas Wagner will show you how to make a configuration, explain an overview of the drive electronics, but you can get also how to fine-tune the motion controller to match motion controller and the motor characteristics, how to operate with non-FAULHABER motors. Also, in this case, you have a short video for this, how to compensate disturbance with tuning, and you have a lot of movie that you can follow in order to get as much information as possible with our motor and motion controllers. So you will find the programming example, programming manual are available in the web page of the products. And let's have a look at some application where you can use this kind of controller. One is when you use an RS-232, is typically a point-to-point communication system where you have a PC with a serial interface. You need a cross cable in order to communicate correctly with the motion controller. Typically, this is a low communication speed. But you can also make a small network, maximum of 8 motion controller nodes, with some limitation. You need one defined node number for every motion controller connected. You need to have one PC, and it's not allowed to have a synchronous response from the motion controller in order to get a correct communication. It's a single master, can send single commands to a single node. There is some limitation. And then also the speed is low, 100 millisecond command synchronization, the maximum speed. So this is for simple application. If you need more complex application with more nodes, with more motion controller connected, then CANopen is the ideal solution. And this is still the standard for a small motion controller. You can have up to 127 nodes in a single network. Typically, we use maximum of 30 because you need to make a shorter cycle time. Otherwise, you need a lot of time to communicate from the master to every slave in 127 different nodes. Typically, this network is split in small sub-networks of maximum 30-32 controller. The cycle synchronization is down to 10 milliseconds at the maximum speed of 1 megabit per second. This is possible with relatively shorter cable. If you need to have a complex machine, then the communication speed must be slowing down to 500 or 250 kilobit per second. And we use the CAA 402 standard. It's a standard profile for the drive electronics. This is a standard. Then you can use this kind of FAULHABER motion controller together with many other motion controllers and motion control systems, also from other manufacturers. There is a need of at least one CANopen master to send all the information to the motion controller. Then we have two types of control. One is a standard profile position or profile velocity control mode, where the acceleration and the deceleration are calculated inside of the motion controller during operation. And the second mode is the cyclic synchronous position velocity or torque mode, where the acceleration and the deceleration are calculated inside the PLC and the external software. In this case, you reach the maximum dynamics possible with our driver. We have an application notes. Let's have a look again in our website. I want to show you where to find it. Go back to the FAULHABER.com website. You go to the know-how section, application notes, and then you can also select here, for example, the PLC setup. You have all the related application notes with EtherCAT or with CANopen. You can have here setup and configuration of a CANopen subsystem. Just open it, and you see how to configure it, how to make a setup of a CANopen subsystem with the explanation of the possible nomenclature that we can use, the topologies, and so on. So we find a lot of information. It's 35 pages of information for your knowledge. Then if you need a maximum performance, then you can use the EtherCAT communication system. We have a lot of nodes available, 100 megabit per second with the minimum latencies, real-time communication bus. And this is ideal for multi-access control in real time. Possible to integrate with different PLC. We have an application note that explain this. We have seen it before with a list of application notes. And there is a natural compatibility of the CANopen subnetwork because we use the CANopen over Ethernet protocol. And other resources, we have seen the drive time movies. We have a lot of webinar. You have seen it before. We have a lot of application notes. So just visit the FAULHABER website, the know-how section, and you can learn a lot of information related to our products. So we are approaching the end of this webinar. Just to recap, you've seen that the motion controller with board-to-board connector can be directly integrated in your own control board. To integrate this, we deliver a lot of information related to application notes, user manual, that this helps you in the integration. You are seeing that the motion manager also have a link to the manual of the product in order to get a lot of information during the configuration of the driver. You have seen that we are using field-oriented control for a very precise motion control, and every FAULHABER motor technology can be driven with these two new motion controllers. The compatibility, full compatibility with CANopen and with EtherCAT allows a lot of application in several application fields, from medical to robotics to lab automation and industrial automation as well. And you get a first-class service assistance from our motion control support directly from the R&D control group that help you to integrate this kind of motion controller in your application. Last but not least, FAULHABER is able to deliver motor combination up to 25 million of different motor combination with gearheads, with encoder, with a screw, and with special connector and so on. But we can also modify our products and to make also customized solution tailored around your application to give you exactly what you need, a complete drive system from a single source. The last page is just to show you the know-how section where you can find information for the webinars. The drive calculator is a simple selector tool where you can calculate the working point of motors to select the correct combination of motor, gearheads, and encoders. The drive time, we have seen it, short video, the application note and tutorial. You have a mine of information for your learning in FAULHABER products. So for me now, it's time is over. I thank you for your participation and see you at the next webinar.